Hey, welcome to the second episode of Distributed.NET Core course. It's Peter
Derek.
and
Yep.
today we'll jump into the code. But before we do it, we'll talk a little bit about CQRS, which we are using to build our system, which is one of the patterns that we are using.
Yeah, I would say that that this one was the one that actually made our code the most extensible and the clean, I would say, because we get rid of the typical typical n-layer architecture, and we decided to split the code using this. I wouldn't say it's actually the design pattern, or definitely this is not an architecture. That's kind of typical to read in articles. But this is more like a good practice or principle. I don't know. What's your thought about this?
Yeah, like dividing the responsibilities in your code and making your code more granular and responsible for small things.
Yeah.
So it's really like single responsibility principle divided into classes instead of methods within your classes.
Yeah. I think that the Greg Young even said that this is the dumbest pattern ever. Yeah. So okay, but I think that we should go to the the definition.
Yeah. So let's go with the right side.
Basically, I think that we should talk about the CQRS, the basic concept. Basically, the CQRS says. But basically, the CQRS stands for Common Query Responsibility Segregation. And basically what it says is that you kind of need two systems instead of one. And one should be especially for the writing to your application, while the other is for the reading. So that is because, these two type of actions are completely different. And it is not, I wouldn't say it's a good practice to actually combine them together. So when you see some methods like, get or create something, it's pretty hard to determine the flow of the execution flow of this method without knowing the state of the application, because for some scenarios this might create an object, while in some others there just might return something from this method. So CQRS basically says that it is better to split your application into two separated parts. It's not necessary you need two separated apps, but it's also splitting as much as you can gives you a lot of advantages, like independent scaling. If your system needs more reading instead of writing, which is kind of typical in the modern web applications, then you can independently scale read side instead of the write side, which is kind of impossible when you keep everything together. So that's, I would say, that the CQRS in a nutshell. So basically splitting writing stuff to your application from reading. Am I right, or I missed something?
Yes, you are correct. I mean, if you are familiar with CQRS already, the CQRS should be pretty straightforward. So basically, if you are using CQRS and, for example, you have interface which has methods like create, which doesn't return anything, and then you have a get method which returns something, you're on a good way. And you can split it into like separate classes, and each class will be responsible for either producing side effects, being writing and handling the command, or getting data would be querying some database maybe. And you can think later about maybe adding separate database for your read models, or maybe splitting your apps into two different ones, and so on. But to start with, it's really easy. You don't need any like distinct databases. You don't need event sourcing, even though it works great with event sourcing. So it's just a simple pattern that you can use right ahead.
I would say that this is the thing that typically CQRS is combined with event sourcing, and that scares people a lot, because they see, okay, so if I want to introduce CQRS to my system, I need some kind of event store, I need some projections, domain models, what the hell is going on? And there is a lot of stuff going, while the CQRS itself, can be implemented easily without event storming, event sourcing.
Yep.
So and the only thing you actually need to do is it's splitting the writes and the reads. But okay, I think that we should go to the briefing about the CQRS itself. So as you see on this slide, basically we want to divide our system into two things, so the write side and the read side. So first, let's focus on the write side, because that's the part of the system that we'll focus today. And first and the foremost, write side and the writings to our application process commands. And command itself is, I would say, that the object representation of the user intention. So when a user wants to change the state of our application, so it can be either creating some domain object or editing some data, he creates the command, so the actual object that contains some data, and this is called by API gateway, and it's processed somewhere in our application. And what is kind of crucial is that you should not think about the command as a DTO, because the DTO itself, so the data transfer object is a simple pattern that actually reduces number of round trips to your API. And the DTOs are basically data centric, so you can think about DTO as a dump container for the data. So this is strictly data centric, while the command itself is more like behavior centric. So this object represents some intention, and the data inside this object is needed just for fulfilling this intention. And what is also important is that the common convention is that the command have imperative names, so like create order or cancel subscription or something else. So basically you will see that all our commands will have the imperative names. Next, because this is the right side, the commands tend to mutate the state. So this is what the CQRS stands for. So the right side is all about writing to the application, so we will mutate the state of our application one way or another. So this can be, as I said, either deleting something, creating, or editing. But because we mutate the state, we will not return any value. And to be clear, returning value is about any kind of data. So this is not only about domain specific data like some read models, but also any kind of booleans or I results, any kind of results that will indicates about success success or failure of our operation is not acceptable when it comes to pure CQRS. We will not return any data. So using other words, the type will be always void or task when it comes to async execution. And for writes, we will use the async protocol. We'll use the QE in our application. This is the RabbitMQ. So you will see this. I think that in the next episode, but we'll come to this.
Yeah.
So that was the right side.
Yeah, and just to be clear, we'll start with sort of in-memory processing of these commands and handlers, and later on we'll move to like distributed processing via message broker. And speaking of the read side, we'll focus on this one more in the next episode, probably, and just to explain it a little bit. So basically, read side is all about processing a query. So when there's a write side and someone sends you a command, like do something, for example, create an order or add a product to database or whatever it is, on the read side, you would say get products or get order details, right? So you'll be asking system to fetch some data for you. So, and just opposite to right side, it doesn't mutate the state. which means that it's idempotent. So I can call the function n times and I will get the same result, like each call. So basically, whenever I fetch the data, I send a query to my service, to my API. It shouldn't do any modification under the hood. I'm not talking about things like writing to the log system, which can be obvious, but just like Darek said, let's say you have this get or create order. So maybe you create an order, or maybe you get an order if it already exists. So it shouldn't happen here. If you call get order, you will just get an order and nothing else will happen. And because it's a query, it has to return the value. And like I said before, it's idempotent. So I can call it as many times as I want. And basically, there is this very simple explanation. If you're thinking about CQRS and you're thinking about querying, there's this saying that asking a question shouldn't change its response or its result, right? So you can ask someone the same question all the times and you should get the same response. So I think that's the most trivial explanation that you can think of.
Yeah, most common one. Yeah.
Yeah, and one more thing. The read side will be always synchronous, and I'm not saying that you will not use task or async awaits, because we will. I'm saying that you shouldn't put your queries into message queue, so it should be always synchronous. We'll talk about it next episode or something.
The protocol for the communication is synchronous since it's HTTP, but the code in C# or whatever language you're using can be asynchronous, but it's just a matter of the communication with the API.
Yeah, you should we should always get the results in some synchronous way. So let's go to this final slide for today about writes.
Final slide, which is second. That's kind of awesome. So we'll discuss very briefly how we structure the flow of the writing to the system. So basically, as you see, and it's kind of obvious, the whole flow starts with the HTTP request from the client side, and you can think about this as some Angular app or whatever you use on a front end. Blazor rocks, by the way, so use Blazor. No more JavaScript. No, I'm kidding. So basically, we start with the HTTP request, which is it might be the delete or post or put or patch in some cases, whatever. So something that actually changes, will imply changes in our state, and this request will contain in the body or in a path, depending on the type of the request, the data for the command. So we'll basically send the command as a user intention from the client side to the API. So let's assume that this is, I would say, create a product or something. So this is our command. This will contain some necessary data, so like name of the product, the price, or the quantity on the stock, whatever. So we'll send this to the API, which is of course called by proper action, and then then the API publishes the command to the QE, so to the RabbitMQ. We will use the publish subscribe method as a communication between the API and the particular microservices, and maybe this is not clear on this diagram, but after publishing the command, API returns the response to the client. So, immediately after we publish the command, we say, we return the response code, which is 202, which is accepted. And it's worth mentioning actually that this is accepted. So we are not saying that, your operation has been successful, or that your product has been created. We just say that we accepted this call, but we don't guarantee that your operation will actually succeed in the future. That is crucial, and we'll get to this, to the implications of that in the next episode. So for the client, the response is, I would say, quite immediate. But since this is the async communication, we cannot guarantee that the command will be received and processed, immediately. This might take a while, few seconds or milliseconds in most cases, but we need to be prepared for, more, for some more waiting for this command to be processed. But, in the near future, we finally got this message, and we, each microservice you will see this in a couple minutes, subscribes to the particular commands. So let's say microservice that will be responsible for products, that will encapsulate the domain, of products, will subscribe only to this particular command that are related to products. So let's say that we have this microservice responsible for products. He subscribed for this create product command, and then he sends this command to the command handler. And in a nutshell, command handler is the class that's in a particular microservice, and this class knows how to interpret this command, this user intention. So the command will be processed, and by processing I mean kicking off some domain logic that is put inside the particular microservices. So as you probably guess, when we have some create product command, the command handler will actually create new instance of the product type, product class, and using the repository pattern, this will be stored inside in this case, MongoDB or whatever database you will use. In our case, this is MongoDB. We'll use the NoSQL. So that's basically the whole flow. It is quite simple. Maybe this looks kind of complicated, but basically this is like a typical n-layer architecture, but we just get rid of this domain services, or in some cases application services. We simply put this logic inside the command handler, and as Piotr said, thanks to the CQRS, we have the one class that actually is responsible for some part of the domain. So in this case, this will just create the product and add it to the database, and we'll just end up with more classes, but the code itself will be way more readable.
Mm-hmm. That's right. Yes, and today we'll get rid of RabbitMQ. We'll just send a command to our service. So our service will act as a separate application. They'll be able to consume the user request and internally handle it using its internal command handler, and then save it into database.
Yeah, we'll skip the RabbitMQ part.
So you can think of command handler as basically services application layer. So instead of some discount, order, product service, you will have separated command and query handlers. And within command handler, it really depends what's your domain. If it's complicated, then you could extract your domain and put some domain services. And the responsibility of your command handler will be just to operate on your domain objects, on repositories, and on your domain services to define this flow, what should be done in which order. But since our business logic, our logic is very simple, we'll do most of the work here in a command handler.
Yeah, I think that's worth to mention that we actually started with one additional layer between the command handler and the repository, and we actually had kind of domain services, but it ended up with just one-liners.
Yeah.
Which actually, this layer pretty much did nothing, so we decided to remove it. But of course, if you will have some, you will spot some domain that you have a lot of redundant code in your command handlers, then it's probably the sign that you should introduce this service layer between the command handler and repository to avoid this. But in our case, that was not an issue.
Yeah, we just wanted to make it simple. Okay, So let's get to the code. We just created a new repository that we'll be using for this implementation. It's called Services Discounts. We added it to the GitHub. You can clone it, and we also added it to the SLN file, so you can grab the new SLN which contains this discount service. And let's open my Rider. And here is my discount service. As you can see, I have it added to my solution. And the discount service doesn't really have anything special. It's just a clear startup, which has been cleaned up. And we have program CS. There is nothing special there. And we have a home controller that only returns this hello message. So we'll start with that. And I also set up in the launch settings the properties, so it starts on port 5010 by default, so it doesn't interfere with other services. And let's start with our domain. We will not be splitting this solution into some sub-projects. I mean, you could, for example, follow the onion or clean architecture or ports and adapters or hexagonal architecture, whatever it is, but basically most of them boils down to the same thing, where you would have this domain, which is the core of your project, which doesn't have any references, and then you would have around that, these repositories as a contracts and domain services using these domain objects, and then you have your application service layer being command handler in our case, and some infrastructural parts, while most of the infrastructural parts in our solution resides in this common project that we are using in order not to implement the same code all over again.
But basically the thing is that this app is, we've already over-engineered this way too much for a simple, e-commerce shop. So it made no sense to introduce additional projects inside, one particular microservice just to create the proper onion infrastructure. This made simply no sense because most of the services are pretty simple.
Yeah, so this is just a single project, and we can have our separation of concerns or the layers as different directories. So let's keep it simple. Okay, let's start with the domain. So I will create a new directory. I will just call it domain. Yeah, and there is a high chance that my writer sometimes hangs up. I think it just hangs up. Yeah, it sometimes does. I think it's the best start.
Did it die?
Yeah, it sometimes hangs up during some simple scenarios like adding a projects or adding classes. So let me restart it, and I will just.
So if you're considering creating directories in your solution, maybe the writer is not the way. No, I'm kidding.
Yeah, it's just sometimes hangs up with directories and classes. But I think if it really hang up, it shouldn't anymore.
I think that we should tweet on and post the link to this video.
Yeah.
They cannot do this to us anymore because we act like fools.
Okay. Let's recreate my directory once again.
We'll see. Maybe it's there.
No, I had to remove it because I'm pretty sure that it wouldn't show it here, and there will be some error. So I will just create it.
But it's loading, maybe.
Yeah, it's loading. Of course, it's loading a little bit slower because of the recording, but it should be there.
Now you can blame your MacBook. It's too slow for recordings. Yeah. Great, Apple. Thank you.
I should record on my Linux.
Okay, there is no directory.
Yeah, let's give it a second try. Yeah, synchronizing.
Now it's synchronizing. Great. Yeah. I think that we should prepare some jokes for stuff like that.
Yeah, just
maybe we'll just
just like in .NET Core, .NET Rocks, we should have these jokes part.
Yeah.
All right.
Yeah. Or just name that framework part when we can just introduce some great frame. Oh yeah. Okay.
Wow, we got it. So let's create a new object. New type. I will call it discount. And we have our discount. And for starters, I will just put there an interface, implement. It's called identifiable, and we just added here in order to have a support for our internal repository. It's a very simple interface that's just telling that we will have our unique ID. So something like this.
Yeah.
But again, if you
are used for the, am I right? This is used for the generic constraints in a repository.
Yeah, but again, if you are if you are coming from DDD world, for example, you could put there something like aggregate ID type, and just have this business ID instead of simple GUID or integer value, but we'll just keep it simple. So I'll put there an ID, and I'll put there the customer ID as well. So each of our discounts will be applied to a particular customer. So let's do it like this. And now let's put there a code. So we'll have a code, for example, secret, which will be used for this discount. And then I'll put there this field called percentage. So our discount might have, for example, 10%, like value of 10%, meaning that you will pay only 90% of the original price. So this field will be responsible for this percentage discount. And finally, one more property, and it will be of type datetime, the nullable type, and I will call it used at, meaning that when someone applied this discount already, you can't reuse it anymore, and we'll check that using just the datetime without any boolean here. So for the starters, I'll create a private constructor, and the only reason I'm doing that is because quite often when you're working with some ORMs that map data to your database, they sometimes may fail if you do not provide here a parameterless constructor. When the ORM is trying to deserialize your data, use reflection to assign values internally, and you only have the public constructor, which...
Oh, I didn't know that you can make them private. I thought that they need to be public.
No, it only has to be, you only need the parameters constructor can be private, which is quite fine.
Maybe it depends on the
yeah,
I
think with anti-framework core you don't even need this constructor, but with other libraries I think you do. So it's really it differs between different arms. Okay, so we'll put there our ID. So because we can.
One more thing, as you see, we as Piotr is currently typing, we do not create anemic classes when it comes to domain. And we want to keep them, all setters, to be either private or protected, and we want to be sure that the entity or the aggregate, whatever you call this, we'll get to this later, is responsible for its own integration as a data and for the validation. So as you see, the Piotr currently is creating some very simple logic. So for instance, whenever the customer provides the incorrect percentage, so the percentage is less than 1 or the more than 100, we want to trigger, in this case we'll just throw the simple custom exception that we created. So it is not like we create an object and we just leave it be. We want to be sure that this will actually be valid object in terms of our business logic.
Yeah, when you're thinking about your domain and you are familiar with domain-driven design, this type would be this aggregate. And like one of the most important part about your domain object is that the domain object should be responsible for keeping its internal state valid all the time. So it should never be in an invalid state. And you can see there are these properties, and they are some of them can be called invariants, meaning that invariants should always have proper values, should always be valid. So, for example, I should never create a discount with an invalid, let's say, code or with an invalid customer ID or anything else, which would actually, which would be the invalid value for some of my one of my invariants. So when you are thinking about validation, you should never create a domain object and then put into some domain object validator interface. You should always internally check. I mean, your domain object should always internally check whether it's valid or not. So all of whether it's constructor, whether it's some factory, whether it's some method that modifies its internal state, it should always ensure that the invariants are valid. So this is very important.
And that is also a good separation of concerns, because I saw that the folks tend to kind of mix a little bit the validation and the persistence code together. So it is like you create some object, then you in some repository you try to validate this, or maybe add some data ad hoc, and then save this to the database or whatever story you have. And sometimes, especially when you're messing up with this too much, like you're adding some, aspect-oriented programming or something, it's kind of hard to actually see, where these properties are actually set. And this is kind of clear because when you create some domain object, in this case, this is an aggregate in terms of, of the domain-driven design, you can see that the discount has, these properties, and this is I would say the valid discount only if if it fulfills the following requirements. So I would say that this is way more readable and easier to understand because you know that once you create an object, this is a valid object and can be safely persisted to the database without any weird mixing up. So the other thing, because we had the constructor and Piotr is now typing some weird magic here. I see the use.
Yeah.
So this is basically the method that, as you see, so we can say that discount, we want to use this. So once again, we're not explicitly, we're not setting the properties because they are private. So now instead of this, we need to invoke the method called use, and this will first check whether the code was previously used. If so, then we just throw the exception. So once again, you see that we're making sure that this is actually the available action for this particular instance of the discount type. And if it's if it wasn't used, then we're just setting this up to the UTC now as a date of the usage.
Don't be barbarian. Always use UTC and then render on your front end the correct value of your datetime.
Or datetime offset. But
so
most cases datetime offset is better, but for this it's just simple and it's fine.
Yeah. So speaking about our domain object, it's pretty much completed. So we have a few basic properties. We have the invariant validation for our constructor, but if the creation of this object would be more difficult, you could always put it into some factory, and they'll be part of your domain. And here we have the use method, which basically uses this discount for the customer that it was assigned to. And you would never like to have, for example, public setter and then just say somewhere in your code, use at equals this or that. You should always have a method there that will check its internal state. Okay, it was already applied from an exception, right? You can apply it anymore. So this is how you can deal with these domain objects. Yes.
And before we we will go further. One more thing. Yes, we know that throwing the exceptions inside the constructor, maybe it's not the best way of doing this stuff, but as Piotr said, you can just create factory for this.
I wouldn't say it's a bad thing. I've seen a lot of people doing it because if you think about setting values.
Speaking of performance, it's not that. I'll just.
It could of performance, right? But the question is, this is really like an exceptional situation here. So someone's trying to pass invalid data, and you could, for example, you would probably always have some validation layer above this domain object. So if your validation layer failed somehow, or let your invalid data, went here, you should probably never create this object internal state, because what else you can do? Return some boolean, produce some error event, or just, if your validation failed somehow, you should never allow to create an object with an invalid internal state. So it doesn't really happen too often, but if it happens, you should be aware that you did something wrong, probably somewhere above. All right, so here's our domain. And before we go further, let's create a repository. And the important thing about repository is I will create a new directory for repositories. But there is a very important thing about repository. Also, I think it's also part of like DDD concept. And let me just create this discount repository. So speaking of repository, what you shouldn't do unless you are doing a very simple CRUD application that doesn't really have very sophisticated logic. So your repository is basically acts as a public contract, which is saying what you can do with your domain object. So speaking of my discount, I could probably have full CRUD like gets, adds, maybe also the update, maybe remove, maybe not, which is fine. But let's say you will have an order, and for the order repository, you would probably want to only have the add operation and get, but most likely you wouldn't like to update your order or remove it, right? So you always need to think in terms of what should I be able to do with my domain object, not just do a typical generic CRUD for your repository all the way. So just keep that in mind. And
basically, Piotr hates the generic repository.
No, I'm not hating. I like generic repository because we even have the generic repository here, but we are using it internally as we are injecting it into our specialized repository, as you will see.
We'll just get this to the very.
So what I can do here, I will just say add async for my discount. And I think for now it will be it. Maybe I'll just add there. Let's put there also update, but that will be all for now. Later on, we'll also put there some get. Okay, let's create a new derived type and move it into another file. I don't know why they put their remove unused class as first option. I always click it accidentally. Moving to a separate file should be a first option available. Okay, so right now we can implement our repository, and since we'll implement the Mongo repository right away, we have this generic type called iMongo repository, and you can
find this in the common.
You can find this in the common library. It's here. So it's in our common. And there are all the extensions for MongoDB, and like Darek said, even though maybe I hate generic repositories, I really like to use them as long as I inject them into some specialized repository. Unless I'm doing very simple CRUD app that I can use.
I want to say this applies only to the repository, but that's just pretty common thing that always favor composition over inheritance.
Exactly.
And that gives you a lot of things, because at first you have this control that the Piotr mentioned, that even though we have the Mongo repository, which is the generic type, we just limit the API for this particular domain part, for the only necessary stuff. And the other thing is that it is way easier to create a proper unit test for this, because notice that when we speaking in terms of the unit testing, in this case we just need to mock the Mongo repository, and then we'll just inject this mock inside our discount repository, and we can verify. Maybe this is a kind of bad example because we just invoke the add async or update async, but when it comes to some querying data, we can actually check whether the filtering or querying mechanism work as expected. So not only this is better option because of the limited API or something, but it's also handy when it comes to unit testing.
That's
we have
right.
This.
Okay.
I think that you forgot to register this.
Now, let's maybe do our container registration before we go further with the stuff. So in our startup, as you can see, I cleaned up a lot of things, and for now I just added this call add custom MVC, which is also part of our extension. It just adds these basic MVC libraries, and interfaces like MVC core, JSON formatter, and so on, because we are not using ASP.NET Core app. We are just using a few NuGet packages from the for the ASP.NET Core app instead of this meta package for ASP.NET Core app, which has like tens of different dependencies that we are not using. And by doing so, we can just focus on building microservices. We don't need to care about Razor views. We need to care about anti-framework and all of these dependencies that we don't want to use. So we can always save a few megabytes of RAM, whether it's disk storage or memory usage. So if you're building services, you can just use of this at MVC core. Okay, so back into my startup. At first I will add the iContainer. So we are using autofuck here as our IOC container. So I'll put my iContainer here. Just beware of this autofuck namespace, as it also resides under system component model namespace. So I added my container, and now I will build it. So here I can say something like container equals. And before I build it, I need to do the following. I will need to create my builder for container, which is container builder. Here I can register my services, calling this populate method. So services, and then I can build my container.
So maybe we should say about this populate method, because maybe some of the folk are not familiar with the autofuck. So basically, okay, as you probably know, the ASP.NET Core provides its own dependency injection container. So as you see, this is iService collection that actually allows you to register the components. So because we're using, in this case, we use the limited APIs of the ASP.NET Core, but even though we have some pre-registered components provided by the ASP.NET Core, so we want to kind of copy paste this to our autofuck container, and for this purpose we need to call this populate method. So we basically says whenever it's registered by the ASP.NET Core, by default in this services object, please just move it to our container builder. So we'll just continue registering new components there.
Exactly. And so let's go with our registration. So I will just do it once, and we won't go back here again. So I can say I want to say something like add initializers, and this is one of our own extension methods. And I want to add an initializer of MongoDB. So what it does basically, it can initialize, for example, some basic data when your application starts, or some conventions. So if I take a look into this class, you can see that I'm just calling these registered conventions here, where I can, for example, use different decimal types for my database. I can store my inodes as strings and so on. So I will just call this add initializers extension method here for our MongoDB, and here I will say the following. At first, I will call an extension, and our extension called addDispatchers. So this one will be responsible for handling our commands and events in memory. As you can see, I'm just setting here up command dispatcher, dispatcher, and query dispatcher. So we'll be able to send the commands to our API and then just process it internally. Then I will say I want to add Mongo. And again, if you take a look at Mongo, it just registers your MongoDB database based on app settings. So it looks for a section called Mongo, it grabs the connection string, registers database, and so on. So simple extension, I think. And finally, I will add the Mongo repository. So again, whenever I want to inject a Mongo repository here, which is a generic type, I need to provide which type I want to use. So I will say that for my discount type, which is this identifiable, which implements this interface, I want to inject this Mongo repository of discount as my generic parameter, and I want to have the discounts collection within my database internally. So we will just store this type in this internal collection in the database. Okay, So we have dispatchers, we have Mongo repository. Now I can return my container. So it's very simple to work with a different container.
Shouldn't you also register the iDiscounts repository besides that?
Yeah, I could. And I can do it like build a register type. For example, we have the discount repository, repository S, iDiscount repository. I can do it like this. But I can also make my life simpler. I can follow some magic assembly scanning, and I can tell build the register assembly types. And I can say my assembly, which is assembly, and for example, get entry assembly, and then as implemented interfaces. And I will just register all the interfaces along with its default implementations within my assembly being discounts project. So I don't need to care about any other implementation unless I want to specify some external lifecycle of this particular object that I'm registering.
Yeah, so for all of you who are as lazy as we are, this is perfect.
Yeah, but just be aware that sometimes you may accidentally override some of your other implementations. So just beware of the order when you are registering your interfaces. Yeah, and finally, in order to make use of this container, I can just say return here iService provider. So basically, whenever you want to inject your your default container into one of your services, and you like to use the service locator pattern, for example, you can just inject iService provider, or within the iService provider, you could create a scope and resolve all services. So here I would just return it, and I will say new AutoFac service provider, which comes from the AutoFac library for ASP.NET Core, and like this. I'm sorry, container.
Container, I would say, yeah.
Yeah, and one last thing. Here, you can do the following. And I can inject here iApplication lifetime interface, and I will say application lifetime, and there are 3 events, and I will register for application stopped event, and I will say register, and I want to be sure that when my application stops, I will dispose my container. So if there will be any like external connections or files being opened, I wouldn't like them to get locked. So I will just call this container dispose and ensure that my application disposes the container properly. Just to be careful. So you can also find this info in the AutoFac documentation.
I think that not only uses this application stopped event and this registering part. I think that most of the people actually create DI containers and then just okay, whenever my app goes down, it's just this probably dispose the container, but it's actually very handy extension.
Yeah, unless you restart your app and you can access the file or something else because it's locked by some zombie process or something. Okay, so what next? I think that we
should start some command maybe.
Yeah, let's go into our commands. And here I will create a new directory and I will call it messages. So here we'll put all of our messages, being either commands or events or even queries. So today we'll start with comments, and let's create a subdirectory called comments.
Nested directory.
Yes.
Hopefully this will. Oh, this worked.
Yeah, this worked. I mean, it shouldn't hang up at least for a while. So I will create a new comment, and the user would like to create a discount, whether it's going to be user or the system administrator. Oh, this discount will be created automatically by some long-running process, whatever the policy is going to be. So I will create discount, and for my command I will say I want to implement here iCommand interface, which comes through our DShop command messages, and iCommand is just a marker. It just says that there is interface of this type and doesn't have any
Once
properties.
Again, this is just marker for generic constraints, nothing more.
Yeah,
we don't require.
So what do we want to pass within our create discount? I want to pass a few things. So I want to pass the ID, since we'll be using GUIDs, and we can state which ID do we want to have. It's going to be the part of my command. Next, I will pass the customer ID,
So basically,
yeah, it should be good.
the data that will actually use to create the instance of discount aggregate.
Yeah.
So basically, everything was there.
And then my code, which will be the discount code. And finally, my percentage being a double type. Okay, so what next? Next, I will initialize this from constructor. And again, I don't know why in Rider they put the constructor above your properties.
I think that can be changed somehow, but I don't
Probably.
know. But okay, but this is a kind of important thing. But okay, but as far as I remember, we had private setters in a domain, but for now I see that each setter is
there is no
here.
setter.
So this is So we have the read-only properties, which means that this message is kind of immutable. So why is that?
Why is that? Because when user sends her intentions, it's just the way it is. I mean, you don't want to modify it. The user said, I want to create a discount, and it shouldn't be able to really modify it. It should be immutable object, right? So we don't wanna change someone's intentions. I mean, you could put their setters, and then maybe modify it somehow because there is a setter, so you can do it. You could even put the private setters, and then will be also fine. But again, if you wanna be like 100% immutable, just put getters. And in order to make it work with ASP.NET Core, you need to do one more thing. Given that you are using, for example, newtons of JSON by default for the JSON serializer, you can just say JSON constructor, so that framework will know how to deserialize or serialize your incoming message using this constructor. Otherwise, you would have nodes there.
One more thing, because you talked about this immutability, we will kinda cheat about this immutability in one place in the API gateway.
Yeah, you'll see where.
Yeah. So for those of you who are from Italy, the pasta something. No, I'm kidding. You will see the why we kinda need to break this immutability to provide more extensible API. So, but for now, let's just assume that in 99%, the command itself and the other messages that we'll actually put on an exchange are immutable. We don't want to mess it up anyway.
And finally, we can do our handler. So let's create a new directory again, and I will code handlers. And again, speaking of your project structure, in a bigger project, what I will usually do, instead of besides having different layers for my core infrastructure and services, I would group this by features. For example, I would have the directory, let's say, called discounts, and within discounts, I would have commands, handlers, and all these things. But since we don't have a lot of features in this service, we can just separate it this way. All right, so let's put there maybe the discount subdirectory, because later on we can also have another handlers, so it won't get messy. And I will say I have the handler for discount, create discount. So I will just call it create discount handler, like this. And this class will implement command handler of discount, create discount command. And that's pretty much it. So if you take a look at the definition of command handler, which resides here, it's very, very simple and very common command handler definition that you can find everywhere. So it accepts the command, which is a message, and then it just consumes it. And that's it. And we have this second parameter here. For now, we are not going to use it. This is something related to sending messages through the bus. So we'll talk about it in the next episode, I guess.
Yeah. And one more thing, as you see, as we described at the very beginning of this video, because this is we're trying to follow the CQRS, because this is the right side of the application. We don't want to return any data from the handler. So in this case, since this is the async version of the handler, we just return task, non-generic. So we'll not return any kind of a result, boolean, no model or whatever.
That's correct. And yeah, let's create our domain object here. So basically, this will be your service application layer, where you would use your repositories, your domain objects, your domain services, factories, anything that is part of your domain, and you would just put this overall workflow, like create this domain object, get this object from using repository, use this factory, and so on, and just complete the overall process. So you wouldn't have here like a typical business logic. It will be just doing all these things in a particular order. So in this case, we'll create a new discount, and I'll just pass here the ID, the customer ID, and the code, and finally my percentage right now. So here is my discount object, which is the domain object. And now I can just call, for example, discount repository at async discount. And again, this is like one of the simplest scenarios. But for example, what we could have here, we could have, for example, here something like, let's say, sort of composite key, where I wouldn't be able to create a new discount if there was a discount for this user ID with this discount code, right? So I wouldn't like to have the duplicate, so I could do some check here before, or some other validation, and maybe now I could, inject here an email sender and send an email message to the user, hey, you have a discount, or some things like that. So this is where all of this flow would happen within this command handler.
Yeah, that's I would say that the most important advantage of using the command pattern itself and using the command handlers, that you can actually extract each domain, or maybe I would say the use case, extract to the proper class when it can be handled the way you want. So whether this need additional logging or something else that would be unnecessary when you would wrap the whole application service or domain service. You'll just extract this to the one particular place when you actually need this. So this is a great thing. It's much easier to read, and to actually understand.
Exactly. And you also later on will be doing the same handler logic for other types, being events and queries. So this is like this pattern when you have a message incoming and you just consume the message in some way. And this is very powerful, as you will see in next episode. I think we have the last missing piece being controller. So,
but I think that we had the handler, but how the heck am we are subscribing to this? Because we talked that each microservice subscribes to the particular message.
Yeah, but right now we are not going to subscribe it.
We're
not going to use the RabbitMQ yet. What we're going to do instead, we'll just have a controller, and we'll be able to call this, send this command directly through the controller and have it processed internally. So let's create a new controller, and I will call it a discounts controller, like this. And it can derive from controller base, which is, again, in the ASP.NET Core, you have the controller and controller base. And the difference is that within a controller base, you don't have a support for your Razor view, so you can return a view here. So you should use this controller if you are just sticking to, default add MVC core extension method in your services collection, and you're just building microservices without, Razor.
More like Web API 2.0 when you familiar more with the .NET framework.
Exactly. So this difference between controller and controller base. And okay, so before we inject here anything, I will just create a new action, and I will call it task of action result. It won't return anything except the status code, and let's make it a post. I will call the root just controller So this magic pattern will bind to my controller name, based on a type. So it will be available under /discounts. And now I can also say that it should be only the post method, nothing else. And I will accept here my command. So I can say create discount as my command. And in order to make it work, I need to do one of the two things. So I could either do this from body, which I don't really like, but finally we can get rid of this and we could just apply API controller, which defines a set of useful conventions, and one of these conventions is that you don't have to do from body. So by default, each data will be bound as from body, and if you like to use from form, you would have to put it explicitly.
Yeah,
so by default, it will be from body, so you don't have to put it anymore. Finally, now let's send it into our command handler. So I could use this iDispatcher type. And let's just inject here dispatcher like this. And dispatcher is a very simple type. It has two methods, send async. So send a command or query async for queries. So this one will be for fetching data. And it's just a composition. So it's using internally command dispatcher and query dispatcher. So if I take a look at the command dispatcher, it's basically a service locator. So I'm passing my container here. And when I'm calling send async, I'm just trying to resolve the particular command handler of this type T, and then I will just invoke this handle method. So very simple stuff, no magic here. Let's get it back into my controller. So there's my discount controller, and here I could say something like dispatcher, and then just send async my command. Right? So at this point, it should just process this command. And I could just return here, for example, either created like this, or I could just have my async task and don't return anything. So it's really up to me what I want to return here. So maybe let's return accepted. I think we're going to return accepted. I mean,
yes.
Normally we should return something like created, because this one will be processed internally. So it will be available right now, but let's just let's just make it accepted for now.
Yeah, just stick to accept, because we'll just we'll switch to API gateway, and this will.
Yeah, we'll switch to this asynchronous message broker later on. So the accepted will be the only code that you will see. And besides behind 200 and okay when getting data. And the last
I thought that we're returning the accepted on the gets, so that would be cool.
Yeah. And last thing, we need to put the configuration for our MongoDB. So I can just copy it from any other service. So let's go to, let's say, product service, and I'll take this Mongo section. And let's paste it here. The copy paste pattern, the best one invented ever.
Yeah, and as you hopefully you've already seen our first episode. So we're using the Docker for running the MongoDB.
Yeah. So in my Docker on my system, I have the Mongo running, and I also have this robot3t here. So as you can see, there is no database yet, but it's running. So I'm connected to my local host. Sorry for this very, very small font, but I'm not sure how to increase it yet. So here's my Mongo connection. It's going to be bound internally through this add Mongo extension method to my container. There's my repository, and I don't need to do any specify any implementation of my command handler into this container, because it's being done here for this assembly type scanning. So let's give it a try. I think it should work. And let's start it into.
You can write in down in the comments whether this will actually work in the first try. I think not, but
whether I think it will work. I'm pretty.
Yeah, we'll see.
I'm pretty positive. Let's see, discounts. And I'll just go discounts.
It's like almost midnight, so I don't think that maybe.
Yeah. All right. Let's debug my discounts. and let's put a handler. So let's put a handler here, and also here maybe, and let's put a handler into our discount handler. So let's put it here so we can see everything here, and just here. Okay, so it started. We should be able to open our localhost 5010. It's running? Yeah, it's almost running.
So slow.
Yeah.
It's running?
Okay, it's running.
Yeah.
So let's refresh the page.
So first win of the day, this actually compiled. The first try.
Yeah. So here's my discount service, and now I should be able to do the post. So how can I do the post? I can do it either through Postman or some other tool, but we'll just stick to our REST client. So let's open the Visual Studio Code now with our REST client extension. So we don't have it, you can just install this one. And let's create a new file. So I'll say new file, and let's call it discounts REST maybe. So I will specify the URL into for my API being, let's make it a little bit larger like this. Localhost 5010, and let's do the post method. So this one will be for creating a discount, and it's going to be the post, and we're gonna post to the URL/discounts. And there is one thing that will fail, which is good, and this command ID will fail, and we'll show you how to fix it. So I just realized that. So we're going to say our content type is application JSON, and you need to specify this header unless, I mean, either way, your API will not know what's the type of data and won't be able to initialize it. So you always have to specify the content type. And next, let's put our JSON body here. So I can say something like customer ID, which can be any GUID. So let's get into some GUID generator, because for now we don't have like a customer database, so we can pass there any GUID. As you can see, we are not validating customer in any way within our handler, so we just put there any GUID.
Yeah, we just assume that it exists somehow.
Yeah, and I can also pass the ID, which I don't want to do, but let's give it a try, because you don't want your end user to pass the ID, but let's just put there some ID for my customer ID, so for my discount ID, so it should be actually bound, and you will see how you can how you can prevent this from happening. And let's put our code. So it's I'll say promo, and let's put percentage, so let's say 20% of discount, and let's click request and see what happens. I think that's all. Send request.
We'll see.
Yeah, I'm not sure if it's okay. It's sent. So let's see. We have our commands, and the command has the proper data, so everything is fine with our command and JSON constructor. So let's say F5. It's processing, so it should hit our dispatcher. Yeah, here's our discount handler repository being injected. Then we are creating our discount object. Let's F10. Discount is in valid state. As you can see, everything is fine. And let's click F5 and see what happens. Whoa, it worked. Finally, great. So when I refresh my MongoDB, you can see there is going to be database discount service. Yeah, that's amazing. I can believe it. And there is my there is my discount saved in the database. So that was quite easy. And the last thing for today, I guess, or it's like tomorrow. I mean, we recorded. We started recording yesterday. Now it's today.
If you'll wait just 3 minutes, this will be actually tomorrow. So
it's 4 minutes.
Yeah. To me, it's like 3.5. Yeah. So
okay. Yeah. So speaking about
for you tomorrow, last thing.
Yeah. Speaking about this ID. So here we are passing ID, and of course it's valid because ID is part of our command, right? If I call create a discount, and I am able to put their ID, and generate it somehow, maybe later on I would like to test this by getting the discount, and I would like to reuse this ID in order to get the data, right? So this is one of the advantages while generating an IDs on your own instead of the database. Of course, it comes with some cost. It's not really best
I would say that that's one of the most typical questions when it comes to CQRS. So how am I actually know the ID of the newly created object?
Yeah. So
if I cannot return any value from the command handler because I cannot return the ID of the created object, so how the heck am I know that?
So there are two things that you can do. The first one is that you violate this rule and you are telling your command handler to return the integer or let's say return an integer or long, which would be the ID of your internal ID. And you always have to be pragmatic, right? So if it's fine, you can just return it, right? You're still fine because you still have this command query responsibility segregation, which is fine,
But if you want to be hardcore, CQRS users, then just use GUID and generate the ID before you actually
but it's not like you really have to use GUID. I mean, you could still use internally, let's say, ID in your database, which is totally fine. But in your command, you could pass your ID as GUID, and then in your, let's say in your SQL database, you would have internally something like unique identifier being GUID, like additional internal key that you would use to retrieve the data. Yeah. And this is like you still have
not necessarily the ID that you will actually use for as a primary key when you're going to some SQL
because when you're actually thinking about your domain objects, this is something that most likely will be stored in your database. But if I were thinking about something like aggregate ID being my business ID, it doesn't have to be really kept in my database, or it doesn't have to be something like primary key. It can be just some additional property, right? Because this is important for my business, right? It's just
once again, you should not, you should not combine the domain with the persistence layer too much, because people tend to think that everything that is in my entity or value object needs to be mapped into the database. It's not. I mean, if this is just if something is not for storing inside your database, just ignore it. It's not the mapping like one-to-one when it comes to domain and your database.
Yeah. So things like IDs in your databases is just infrastructural concern. It shouldn't affect your domain at all. Of course, in a typical apps, there is always some ORM, and you have this fluent mapping, and your ID is integer or long, and so on, and it's all the same. But in an ideal world, if you want to be like this purist when it comes to domain-driven design and other patterns, it shouldn't affect your domain objects at all.
Yep.
All right. So what can we do about this ID? What I can do, for example, in my discount controller, I could sort of blacklist this property. So this will be blacklisted, and meaning that the user of the API would be never able to assign it anything. So even if I was to send my ID to the postman, it wouldn't be assigned to my command. That's one thing that I could do. I could also do something like here. For example, I could generate it like this, right? Let's say like this, or maybe better, something like ID equals, is it empty? If it's empty, then create a new ID. Otherwise, use the ID, right? So if it's blacklisted, it will be always empty. But if I'm, for example, writing unit test, the ID will not be blacklisted, and I will put there whatever I want. But the last thing we can do, and what we're actually doing in order to make our life simpler, is using some extension method. Because right now, if I wanted to assign this ID for this controller, I would probably have to do something like new create discount and basically recreate my command simply by copying the values, right?
Yeah.
Which I could probably do using Automapper or some other library, but I don't want to do it. So I can do something like command dot. And there is this extension method. One is called bind, and the second one is called bind ID. So I can say bind ID, and I will just say comment ID. So what it's going to do, it will just assign the unique ID into my ID property, right?
Yeah.
So if I look at this beautiful code here
It
in my
uses the
extension,
reflection.
yeah, this is just a reflection code, and the bind property allows you to assign any value to selected property on your class using the lambda expression, and bind ID is just an extension, so it will assign the GUID by default. So you just need to pass the property being of type GUID.
Even though you have just explicit getter and there is this is a read-only field, you can still assign this.
So this is like being immutable, but we just decided that for these IDs, we don't want to have mappings.
It's much cleaner to do this. So that was the thing that I mentioned some time ago, that we actually, this is the command itself is immutable, but in some cases, and this case is the ID. We don't want to provide this from the from the client. We want to generate this on the entry in our application. So yeah, if you think this is too much for you, this is a hack, and you want to get rid of this, just simply don't do it. Don't use this extension, and you'll achieve this the same result.
Yeah. So I think this is pretty much for today.
Yeah, I think that that was kind of long thing.
Yeah, and we'll just publish this code to the GitHub repository, so you can download it and you can follow it on your own. We'll also tag it, so you'll be able to jump between different tags for the episodes if you like to get back to some point in the past or in the future. And in the next episode, you'll see how we can actually go one step further and quite easily refactor this command handler and this dispatcher here and start pushing our messages into the message broker being RabbitMQ.
Yep. So so I think that's it. Once again, please write down in the comments what do you think about this. If you have some questions, don't hesitate to write the comments. I think that at some point we'll just collect all the questions from the from the forum, from the Gitter and from the YouTube, and we'll just maybe we'll do some short Q&A or something. And and follow us on Twitter and subscribe us on YouTube. We'll probably publish some new video. I think that this year.
Yeah,
right?
This year for sure.
Yeah,
at least one.
Yeah, at least one. So
okay.
See ya.
See you.